So sometimes you'll see functions that are defined by different equations in different parts of their domains. These are called piecewise functions. So I gave an example of one here. We have f of x equals 2x plus 3 if x is less than 0, and f of x equals negative 1/2 x plus 3 if x is greater than or equal to 0. So let's go ahead and graph this together. In order to graph this, I'm going to break it into two pieces. So the first part of it is when x is less than 0. So when my x value is less than 0, I am going to have a graph that looks like y equals 2x plus 3. And when my x value is greater than or equal to 0, my graph is going to be negative 1/2 x plus 3. So you might realize that this 0 is a pretty important part of the graph. This is our cutoff value. So what I like to do at that point is I like to draw a vertical dotted line. The dotted means it's actually not part of the graph. So you don't need to draw it, but it might help you to either draw it or just to visualize that. That's going to be my cutoff. So I'm going to start with the one in red. When x is greater than 0, my graph is y equals negative 1/2 x plus 3. Sometimes it'll help if you draw an XY table. You don't have to, but I think for most people it'll be easier. I know that you can graph these lines without that. So I'm going to start at 0. I'm going to go up to 1, 2, 3. You'll notice I only chose values that were 0 or greater. So when I do that, I get these values right here. Okay, so then you're just going to draw a graph there. Since I have x is greater than or equal to 0, I am going to have a closed circle right there at 3. And then I'm going to just draw my other points. I always just like to draw my the whole numbers if I have them. Keep in mind you only need 2 points for a line. But it's going to end up looking like this right here. So that is, by the way, there should be an x-intercept at 6. Since I'm drawing it on my iPad, I didn't get it perfect, but if you want to be exact, if you're doing it on your paper and you're using a ruler, it should be 6. Okay, so we did the first one. The second one, we are going to look at things when x is less than 0. I'm going to tell you right now the number one mistake people make on this. So people like to say, okay, less than 0, I'm going to start with negative 1, then negative 2, negative 3. Those are fine. Those actually all will appear on this graph. I'm going to plug in negative 1, negative 2, and 3 into that equation. That's going to give me 1, negative 1, and negative 3. So that's fine so far. I'll draw those points. So I get a point right there, I get a point right there, and I get a point right here. So that's what I have right there. Here's the problem. Between 0 and negative 1, that area right there is still in the domain of my graph. So I have a big empty space between negative 1 and 0, and I should not have a big empty space there. So actually what I'm going to do is I am going to include x equals 0. So when x equals 0, that graph is also going to be at 3 like the previous one. And when I draw that, usually, sorry, this should be a line. Usually I have an open circle. Actually though, because because this, the red part of the graph is also at 3, we don't need to show the open circle. I'll give you one where it doesn't connect like that. We can just draw it like this. I am going to tell you that the other way that you can draw this graph is by, I'm not going to show it, but you can try it on your own, or if you want to see it in class, during class time, ask me about it. I'm happy to show you. So the other way that you can do this type of problem is you can draw this first equation, graph y equals 2x plus 3. Then when you, once you've drawn it, you can erase everything greater than 0. And then do the same thing for y equals negative 1/2 x plus 3, erase everything less than 0. That will also give you the right answer. Now, you don't need to do that. I think most people, when they're first starting out, do this method that I just did. But once you get really good at these, I think that method actually might be faster. You probably will prefer that. Our second example is a little bit more complicated. So we're going to graph this same thing. I'm going to just do it step by step. So my first part of it, I am going to graph that as y equals negative 2x plus 1. That is going to be true only when x is between negative 3 and positive 1. So once again, my preferred way of doing this is to do an XY table. If you would like to try just drawing it by hand, you can. Then you're just going to have to erase the parts that are not between negative 3 and 1. So since I know that my domain of this part of the function is between negative 3 and 1, I'm just going to choose the numbers negative 3, negative 2, negative 1, 0, and 1. You don't have to choose all 5 of them, but I think it's helpful to do that. So that gives me a point at 7. That then I have a point at 5, a point at 3, a point at 1, and then a point at negative 1. So then I'm going to draw, plot out those points right here. Keep in mind that this first point, the negative 3, 7, that is going to be a closed circle because I have that x is greater than or equal to negative 3. So closed circle right here at negative 3, 7. I also have a point at negative 2, 5, negative 1, 3, 0, 1, and 1, negative 1. The other thing is that 1, negative 1, that is going to be an open circle because of this less than sign. It's not less than or equal to. So it is going to look like that. And then once I get to 1, negative 1, it's an open circle there. So this is what it should look like. Let's go ahead and let's look at the second part of this equation. And this middle part is, sorry that it's a little bit messy, that is telling me that y equals 2, keep in mind all of these are y equals, if x equals 1. That's it. There's no line, there's no extra parts on the graph. So this is just telling me that the point 1, 2 is a part of my graph. So that's right there. The last thing I have x squared if x is greater than 1. So that's telling me that y is going to be equal to x squared if x is greater than 1. Once again, make sure that if you do a table, or even if you don't do a table, you do include 1 as one of the values. I'm also going to have do a point at 2. So when x is 1, y is 1, but remember, this is an open circle. When x is 2, y is 4. You can do 3, 9 if you have a little bit more room than I do. So I'm going to go ahead and draw these. So I have a open circle at 1, 1. I have a point that doesn't really look circular, but I have a point at 2, 4. This is a parabola. As I said with the previous one, if you would prefer to draw the parabola without plotting points and then just erase stuff later, you can do it that way. So this is what my graph looks like. By the way, you don't need to do it in different colors. I just like to do the different colors so you can see the different parts of the graph. The last example for this section is actually it's a lot less work because you don't have to graph anything, but people sometimes have trouble understanding what's going on. So we're going to start and we're going to take this function. The first thing we're going to do is evaluate f of -1. So a lot of people get confused because they see 2 equations above and they know that they only need one answer, however. So what you're going to do is you're going to look at this value -1. We know that that is less than 1, looking at the domain here. So you're going to use the x is less than 1 equation, this one right here. So we are going to do f of -1, plug in -1 to our top equation, top half of the equation. That gives us -5. For the next one, same idea. We know that 4 is one of the x values that's greater than 1, so that means we're going to use our bottom equation. So f of 4 is equal to 5 times 4 plus 1, or 21. So then the last one, this one sometimes is confusing for people. You're going to have to figure out if this is going to be greater than or equal to 1 or greater than 1. And because it's, less than or equal to 1 or greater than 1, because it is equal to 1, we're going to use that one that's less than or equal to 1, which is the 3x minus 2. So we're going to get 3 times 1 minus 2, or 1.